Hi, everyone. Good morning. My name is Mohammad Shahrad, and I'm an assistant professor at the University of British Columbia. So here I'm going to talk about some of our thoughts on a future where we're going to have multi-cloud serverless computing and a recent project that we've been working on towards this goal. As most of you are experts in the area of serverless computing, I don't think I have to convince you all that serverless is amazing. To summarize, one can say that the end goal of serverless is to help developers build scalable and easy-to-use applications without worrying about provisioning aspects. And of course, that is a powerful vision. We've been getting there more and more every year with fixing the rough edges, but still many problems remain in the area of serverless. For instance, reasoning about function boundaries is a problem for developers. Right-sizing functions is still a problem. Efficient data sharing can become a bottleneck. Lack of meaningful SLAs still hurts developers. And specifically today, I'm here to tell you more about how we can help developers deal with vendor lock-in issues. So in 2021, at the SOC conference, we had a vision paper about the merits and viability of future multi-cloud serverless computing. And interestingly, there was another concurrent work by folks at Berkeley where they talked about the vision of sky computing. So around that time, the community started realizing that there is this potential of even raising the level of abstraction beyond our existing clouds. And that would enable more niche cloud markets to happen under the hood, and also helping developers building applications without worrying about choosing one of the 300 different VM types or setting all these different knobs in their cloud deployments. So back to the multi-cloud serverless vision. Just so that we're on the same page, you can think that here a developer is themselves in charge of building this multi-cloud system. Of course, that's not ideal and defeats the purpose of serverless, which is trying to free developers from the provisioning overheads. So perhaps a better version of a multi-cloud serverless would be where we have an entity, maybe let's call it virtual serverless provider. It could be a framework, it could be actual provider that sits in the middle and provides this illusion of infinite serverless, right? Which under the hood might be connected to this region on AWS, to that other cloud, and so on and so forth. You can also envision a multi-cloud serverless where clouds are natively connected to each other. And it might appear that this would be shooting yourself in the foot if you're a cloud provider to enable this feature. But I think there is merits to that, and it can expand the market and enable new types of applications. Anyways, back to why multi-cloud serverless makes sense. Of course, the most obvious reason would be to leverage differences in pricing model, right? So we're all familiar with how different cloud providers charge you in the serverless domain. Of course, this is a simplification. Each provider has their own discounts if you use this architecture or if you use it for this much, and so on and so forth. But even simple things like how the minimum duration of your function executions is calculated might have an impact. So if Azure Functions on IBM is charging you for at least 100 milliseconds, and your functions are always below that, maybe you don't want to deploy your function there, right? But these rules change, maybe as part of your workflow. Some of the functions are short, some of them are long. And all of these are things that you don't want to have the developer worry about. And it goes deeper than just differences in pricing model. The memory allocation is different. The resource allocation can be very different. Keep live policies that affect the gold star behavior can be different. The concurrency limits are different. So one way of looking at why multi-cloud serverless makes sense is try to take advantage of these differences. You can also try to leverage similarities between these. One similarity is all of these cloud providers, one way or another, they're going to experience very low during the day. So this is the data that we have collected for serverless in the wild paper that characterizes Azure functions. And there we clearly saw some diagonal patterns in the amount of traffic that comes and hits these serverless applications. Now, the cool thing is that this is from the provider side, but from the developer side, also this can be measured. So on the top right, there is some data from Ginsberg et al. In 2020. They measured performance of AWS Lambda functions over a long period, and they saw that actually for certain functions, you can easily sense this diagonal pressure on the provider. And this is some recent data on the bottom right from, I think a month ago at the Sesame workshop, it was presented. And they clearly show that the frequency of unexpected cold starts perfectly matches the hour of the week, right? Not only you have these diagonal patterns, but also over the weekend, nothing crazy happens. So a virtual serverless provider can basically try to monitor these QoS variations and try to leverage the best cloud or best region of the cloud at a given time. Different ways to think of why this is useful. You can basically aggregate the free tiers of different clouds. You can bring compute closer to data from different cloud provider, because now these functions are short, and you can, instead of moving the data, bring the compute to where it needs to be. Maybe you have data residency regulation like in Canada, or you have GDPR regulation for European users. So unlike federated clouds that was proposed before, that VMs are large and they're slow to spin up and incur costs even without being used, serverless really offers an opportunity here, because we can move them around easily in a cheap fashion, and they will only cost us actively when we're executing them. Of course, there's some migration costs, but compared to the execution costs, that's negligible. So to understand whether or not this was viable, we did some early experiments in that paper. We saw that actually you can expand the benefits of concurrency, even though your data might be residing on only one of your clouds. And we injected some anomaly, and the system could quickly adapt itself and pick the cloud that offers best performance. So this was all promising. And based on that, we thought one angle to pursue is to try to build a system that migrates serverless functions, right? So maybe we don't want to have a whole multi-cloud serverless offering, but what if we could just migrate functions from the serverless to alternative hosts, maybe a VM that is underutilized, to a laptop, to a server, to reduce cost. And we built this system called UnFaaSener that is going to be presented at ATC in July. So if you're around, please come to our talk. So in this system, basically, we show that you don't need even much support from the provider. But without any change to their platforms, just using PubSub services, we were able to build this extensive offloading system. And we do it even without adding a scheduler to the critical path. So all offloading decisions are pre-solved by a fairly complex solver and just written there for one tiny header function to look up based on arriving traffic. So testing on different DAG structures, so these are workflows that you can build on top of functions, we were able to get almost 10x cost reduction with hurting the performance only a little bit, right? So the system basically enables developers to communicate whether they are cool with latency being added, or if not, how much tolerance they have, and takes that into consideration. So that's why you see both the cost mode and latency mode results here, and we compare that to existing ways to build workflows, such as AWS step functions, Google workflows, Google functions plus PubSub, or AWS Lambda plus SNS. And you see that latency doesn't get increased as much, specifically if your application has some legroom in terms of a Slack. And we can leverage that to reduce cost significantly. So to sum up, we might naturally move towards a multi-cloud serverless deployment in the future, considering that there are differences between different providers and complexities involved. It might make sense to build frameworks or brokers that help developers in this journey. And in our latest work on UnFaaSener, we've shown that efficient offloading of service functions is indeed possible. So I look forward to chatting with you. And if you have ideas in this space or things that you think is worth exploring, I would be happy to hear about that. Thank you again for your attention.